Hello, this is Mr. Sorry, and welcome to Cyber Day, your very first Cyber Day at GAC, and mine too. Hopefully, we can make this a productive and quick day so you can get on and do what you want to do today. So, please get out your Section 2.2 notes. Notice the steps to solve variables on both sides of an equation. So this is the Section 2.2. And if you'll compare the steps to solve with the notes that we took on Friday, section 2.1, which was on steps to solve a multi-step equation, recall that it was distribute. If there's a parentheses, like this one, you didn't have to distribute because there was no parentheses. But notice with this one right here, there is a parentheses, so our first step would be to distribute. So remember, distribute, then combine like terms, then solve, which means getting x by itself, getting the variable by itself. Well, when we're solving multi-step, when we are solving an equation with variables on both sides, it's still the same first two steps. Distribute, then combine like terms on each side of the equation. But the step that we're adding is we are moving all our variables to the same side. And what I'm referring to there is the same side of the equation. And then we solve it like normal. So let's try an example. So number one here, we've got, I'm just going to copy it onto paper. 5y minus 8 equals 3y plus 12. So this is example one right below at the top of section 2.2. So notice there are no parentheses here. So we do not need to distribute. Next, we look to step 2, which is combine like terms. Are there any like terms on this side, on the right side of the equation here? If you answered no, then you're right, because there's a y term, which is a variable term, and a constant term of 12. On the left side, we have a constant term of negative 8 and a variable term of 5y. So notice how there are no like terms that we can combine here. So now we have to decide which side we want to move the variables to. This is step 3, recall. Move variables to one side. So I'm going to move all my variables to the left side of the equation. So here's what I'm going to do. I'm going to show you two separate problems. One where I move the variables to the left side, and one where I move the variables to the right. Again, it does not matter which one you do. Okay, so I have two identical problems here. On this one over here, I'm going to move all my y's over here to the left side of the equation. So in order to do that, I have to subtract 3y from both sides, because that'll remove it from the right side of the equation. So I subtract 3y from both sides, and I'm left with 5y minus 3y, which is 2y minus 8 equals 3y minus 3y is 0, and we're left with 12. So 2y minus 8 equals 12. So now I solve this. What our next step, think about it for a moment. Our next step is to add 8 to both sides, leaving us with 2y equals 20. And now I divide by 2 on both sides to finish. So y equals 10 is our answer. So now, notice, I started this by distributing, but we didn't need to for this one. Second step is to combine like terms. Again, we're looking back at the top of section 2.2 notes. So there's no like terms to combine on either side either. So now we decide which side of the equation we're going to move our variables to. So I decided for this one we're going to move all the variables to the left side. So notice I have y's left on the left side. So let's say I instead decided to move them to the right side. Again, I want to stress, it does not matter which one you do. So in order to move the variables to the right side of the equation, I want to get rid of this 5y. So to do the opposite of this positive 5y, what would I do? Well, I would subtract 5y from both sides of the equation. Again, remember, this is the same exact process. I'm solving each of these, and I'll get the same solution. But I just want to show you the two different ways and stress how it doesn't really matter which side you move the y to. Okay, so 5y minus 5y is 0. We're left with negative 8 equals 3y minus 5y is negative 2y plus 12. Okay, so continuing. Our next step is to subtract 12 from both sides. Subtract 12. So we get negative 20 equals negative 2y. And finishing it up, divide by negative 2, divide by negative 2, we get 10 equals y, which we can rewrite as y equals 10. So notice, each one of these got us to the same place, y equals 10. But for this one, we move the y's over to the left side. And for this one, we move the y's over to the right side. So recall, after getting your y's on one side, we want to move the other stuff to the opposite side of the equation. Okay? So let's try another one. Let's look at let's look at number 7. Number 7. It's at the top of the second page of the notes. So number 7. This is number 7. Okay. So number 7, I'm just going to recopy it. 3 parentheses 6p minus 1 equals 11p minus 45. And remember, our goal is to solve for p. Solve for p. So our first step, if we look at the top of the notes, says to distribute if necessary. Is it necessary to distribute in this problem? If your answer is yes, then you are correct because we have a parentheses with a coefficient out front. So we're going to distribute this 3 into the 6p and into the negative 1. So I have 18p minus 3, that's 3 times 6p and then 3 times negative 1, equals 11p minus 45. Okay, so second step is to combine like terms. Are there any like terms on the left side of the equation? I have a p term and a constant term. Can't combine those. On the right side, we have a p term and a constant term, so we can't combine those either. So our next step after that is to move the variables to one side. So I'm going to subtract 11p from both sides. Subtract 11p from both sides to get the p's over to the left side of the equation. Okay? So we're going to subtract 11p from both sides. Cancels out of the right side, and we're left with negative 45. So negative 45, that just came down. 18p minus 11p is 7p minus 3. So I've got 7p minus 3 equals negative 45. Our next step is to get the other stuff to the other side of the equation. So we want to add 3. And we're left with 7p equals negative 45 plus 3 is negative 42. And then our final step to solve for p is to divide by 7. So p equals negative 6. And we are finished. So notice the only difference between what we're doing in this new section and what we did in the previous section is that we have variables on both sides after our distributing and combining like terms. So once we get to this step where we have variables on both sides, we want to choose a side to get them to. So here I chose, let's move the p's over to the left side. So I subtracted 11p on both sides, getting rid of this 11p right here. Questions? Please email me your questions if you have any. Hopefully this has been a helpful video. Recall that the entire key to the notes packet is available on campus, as well as in the same place as the place you'll find this video. Again, hope you guys are having a great day, and good luck with the homework.